The construction of the lunar robot began in early January of 2006. At the beginning of this project, much time was spent in the machine shop working on the mechanical portion. With the four of us being electrical engineers, the decision was made to keep the project mechanically simple. For simplicity, we literally avoided reinventing the wheel by using stock items whenever possible. When new parts needed to be manufactured, familiar and easily workable materials were used. These materials were usually available at local stores so new ideas could be quickly implemented. We had a great deal of valuable help and overall learned there is an easy way to machine and there is a hard way. For this robot, we had to cut, grind, mold, and weld the main frame. The first part to be made was the base and drivetrain. Originally, only 4 tires were used. This design worked successfully on cement, but did not perform as well in the sand. As a result, 4 additional tires were added to provide more stability and maneuverability. Tests were done again in the sand, and the robot responded far better in both straight movement and turning. The remaining mechanical portions of the robot were built and assembled over the next few weeks. Progress was slow at first, but eventually the robot began to take form. Finally, the robot was ready to be taken out of the machine shop and moved back to Strank Hall South. The next steps of assembly had much more of an electrical engineering aspect. In the design process, we had created schematics which were first converted into printed circuit boards. These printed circuit boards were ordered and then assembled piece by piece with the corresponding components. Outside of the robot, each function of the board was tested to ensure proper operation. The board was then wired and installed into place. The remaining wiring of the robot was accomplished in about a week. The wiring was perhaps the most tedious part because each wire had to be neatly placed and correctly documented. In parallel with this wiring, the programming of the microprocessor was also being completed. The microprocessor and computer station were the key components in control of the robot. Once the robot was assembled, wired, and programmed, a full test demo was attempted in the sandbox. Some of the tests went well. Others did not.
Stop!
After a few minor modifications, however, the robot performed correctly in every design goal task. We were able to perform a successful run using only the cameras on board the robot, and the final airlock test went perfectly. We were ready for Texas. Start of the competition. They're burying the box inside the sand.
How you doing?
You guys are on alert now. You're not allowed to go back there anymore.
Yeah.
Digging you in, so.
I don't think we've ever driven home that far.
No.
Almost.
I'll show.
There you go. There you go. Yeah.
Okay. Yes, sir.
first place seat, University of Akron.